Hello, everyone, and welcome back to our show. I'm Tom.
And I'm Amy. It's great to have you with us today.
Today, like every Thursday, we're diving into the topic of people who are important to the world. We'll take a closer look at the rich life story of Albert Einstein.
Mm-hmm.
Most of us know him, as the face of genius, that iconic equation, E Merceo to know.
Right, the hair, the equation.
Exactly. But there's so much more to his journey, his struggles, and, well, his profound impact on the world, way beyond just physics.
That's so true. Our mission today is really to sift through all the information out there about Einstein. There's just so much.
Yeah.
And we want to pull out the most compelling details, the insights that maybe get overlooked.
Uh-huh.
We're aiming to reveal not just, the undeniable scientific brilliance, but also the fascinating, deeply human person behind the icon.
A real person.
Yeah, a man full of surprises, contradictions sometimes, and this unwavering moral conviction, too. It's a story that goes, well, far beyond the blackboard.
Okay, let's do it. Let's peel back those layers.
Mm-hmm.
Our journey starts in Ulm, in the German Empire.
Mm-hmm.
Albert Einstein was born there March 14th, 1879.
Mm-hmm.
His parents, Hermann Einstein and Pauline Koch, were secular Ashkenazi Jews. His father was a salesman, an engineer.
Right. And they moved to Munich pretty soon after he was born.
So what are we looking for, that early spark,
Mm-hmm.
in someone who, would change the world?
Well, what's really fascinating is how early that spark, that deep curiosity seems to have ignited.
Oh, yeah.
Einstein himself often told this story from when he was young. He was sick in bed, maybe 4 or 5 years old.
Okay.
And his father gave him a simple magnetic compass.
A compass.
Yeah. And it wasn't just a toy for him. It completely captivated him. He felt there had to be. His words were something like, something deeply hidden behind things,
Wow.
some unseen force guiding that needle. It was more than just watching it. It was the start of this lifelong fascination with electromagnetism, with unseen forces, and this real drive to understand the underlying mechanics of everything.
Yeah.
It really shows how these seemingly ordinary moments can plant these huge seeds.
That's a powerful story. Just
Yeah.
one object setting a mind off on this incredible path.
Exactly.
So he went on to school, St. Peter's Catholic Elementary, then the Luitpold Gymnasium in Munich.
Yeah.
But interestingly, he really didn't like the way they taught things.
No, he didn't. That strict rote learning style common in German schools then.
Yeah.
He found it really off-putting. He later wrote he felt it was harmful to creativity.
So an independent thinker right from the start,
Yeah.
even pushing back against the system then.
Absolutely. You can see that thread, that questioning of established methods running through his whole life, really.
Mhm.
His family later moved to Italy, Milan first, then Pavia. But Einstein, surprisingly, stayed behind in Munich for a bit.
Oh, really? To finish school?
Yeah, before eventually joining them. And it was actually during his teenage years while in Italy that he wrote this essay.
An S.
Get this title. On the investigation of the state of the ether in a magnetic field.
As a teenager. Wow.
Yeah, already grappling with these huge concepts that would become central to his later work. The ether, magnetism.
That's incredibly precocious.
Yeah.
But it wasn't just science, was it? His interests seemed broader.
Oh, definitely. By about age 13, his interests really expanded. Music became very important to him.
Violin.
The violin, yes. And philosophy, too. He was introduced to Kant's critique of pure reason around that age.
Caught at 13. That's intense.
Right. And the story goes that these works, which are, let's face it, incomprehensible to ordinary mortals, as someone put it,
Yeah.
somehow seem to be clear to him. It just hints at this incredible intellectual breadth and depth. He wasn't just a physicist in the making, he was a philosopher, too.
So talking about his academic path, it wasn't exactly a straight shot to the top, was it? Even for Einstein.
No, not at all. It's actually kind of reassuring in a way. At 16, he tried to get into the Swiss Federal Polytechnic School in Zurich.
The ETH Zurich, right. Very prestigious.
Exactly. And he actually failed the general part of the entrance exam.
He failed.
He did. Though, importantly, he aced the physics and math sections.
Ah, okay. That makes more sense.
So he had to go finish his secondary education first in a town called Aarau in Switzerland.
Right.
Then he got into the Polytechnic, and he eventually became a Swiss citizen too, which he kept his whole life.
It's good to know even Einstein had some academic bumps in the road.
It absolutely is, and it shows his persistence, I think, because even after graduating in 1900, finding a job wasn't easy.
Really? You'd think.
I know. He struggled for almost 2 years to find a teaching position, sending out applications, getting rejections.
Wow.
Finally, he landed what sounds like a pretty mundane job, actually, at the Swiss Patent Office in Bern.
The patent office. Seriously.
Yep. From 1902 to 1909, he worked as an assistant examiner level 3. Can you just picture it? The guy who's about to rewrite physics, sitting there evaluating patent applications.
It's incredible, but, maybe that ordinary job was actually good for him.
How do you mean?
Well, maybe it gave him mental space, like away from the publish or perish pressure of academia. Time to just think those huge thoughts without interruption.
That's a really interesting point, and many people think exactly that. The job gave him a steady income, wasn't overly taxing,
Right.
and it left him time and energy to pursue his real work, his own theoretical physics.
And boy, did he use that time well.
Oh, absolutely. Which brings us neatly to 1905, his Annus Mirabilis,
The miracle year.
the miracle year. It gets compared to Isaac Newton's big year in 1666. That's how huge it was for physics.
And rightly so. In just 1 year, he drops 4 papers that basically change everything.
4 bombshells, all while working at the patent office.
Amazing. So what were they? Let's break them down.
Okay, first there was his paper on the photoelectric effect. This is where he proposed that light isn't just a wave, but it's also made of these localized particles, or quanta.
Which we now call photons.
Exactly, photons. And this wasn't just a neat idea. It actually explained experimental results that classical wave theory just couldn't handle.
And this is crucial. This is the work that actually won him the Nobel Prize later, in 1921, right? Not relativity.
Precisely. That's a point that often gets missed. His work on the quantum nature of light was revolutionary in its own right and foundational for quantum mechanics.
Okay, so that's one. What else came out of 1905?
Then there was his paper on Brownian motion, the random jiggling of tiny particles suspended in a fluid. His paper provided really strong theoretical evidence that this jiggling was caused by collisions with unseen atoms or molecules. This was huge because the actual existence of atoms was still kind of debated then.
Right. It helped solidify the atomic theory.
Definitely. Okay, third paper, the special theory of relativity.
Here we go.
Yeah. This was his brilliant way of reconciling 2 major pillars of physics that seemed incompatible.
Maxwell's equations for electricity and magnetism and Newton's laws of motion.
Exactly. They didn't quite work together, especially when things moved really, really fast, close to the speed of light. Einstein's genius was figuring out the connection.
Which led to some pretty weird ideas, like time slowing down.
Time dilation, yeah. And length contraction things actually getting shorter in the direction of motion at high speeds.
Yeah.
Mind-bending stuff.
And in doing this, he basically threw out the idea of the luminiferous ether, didn't he?
He did. That hypothetical substance everyone thought light waves must travel through, Einstein just said, nope, don't need it, it's superfluous. A massive conceptual cleanup.
Okay, photoelectric effect, Brownian motion, special relativity. What's the fourth?
The fourth paper was almost like a consequence or a follow-up to special relativity. It's where he derived the most famous equation in the world, E equals mc2.
Mass-energy equivalence. The idea that mass is a form of energy and vice versa.
Exactly. That tiny amounts of mass contain enormous amounts of energy. These 4 papers, all in 1 year, it just completely reset the landscape of physics.
Unbelievable. So after a year like that, the academic world must have finally taken serious notice.
Oh, absolutely. His career really took off after 1905. From 1908 onwards, he started getting academic appointments.
All right, you mentioned Bern, Zurich, Prague.
Yep, University of Bern, then Zurich, then Charles University in Prague, back to ETH Zurich, and then the big move to Berlin around 1914.
Berlin was a major center then.
Huge. He was associated with the Prussian Academy of Sciences, Humboldt University, and became the director of the Kaiser Wilhelm Institute for Physics. This was his period of peak academic prominence in Europe.
And it's during this time, this climb up the academic ladder, that he develops his next big theory, right? General relativity.
Exactly. General relativity was his magnum opus, really. He worked on it intensively between about 1907 and 1915.
What was the core idea behind it? Special relativity dealt with constant speeds, but general relativity brought in acceleration and gravity.
Precisely. It started with his equivalence principle. This was a thought experiment. Imagine you're in a closed box, like an elevator, out in space, accelerating upwards.
Yeah.
The feeling you'd have being pushed to the floor would be indistinguishable from the feeling of gravity if the box were just sitting on Earth.
So acceleration and gravity feel the same.
They're equivalent, locally. And from that insight, he made this incredible leap. Gravity isn't a force pulling things together like Newton thought.
Yeah.
It's the curvature of space-time itself, caused by the presence of mass and energy. Massive objects literally warp the fabric of space and time around them.
Wow. Okay, that's a huge shift in thinking.
It is. And it made some completely new predictions. Things like time should actually run slower in stronger gravitational time dilation.
Time runs slower near massive objects.
Yep. And also that light itself should bend when it passes near a massive object because the space-time it's traveling through is warped, gravitational lensing.
Okay, so how do you test something like that?
Ah,
Bending starlight.
well, that brings us to 1919, the total solar eclipse. This was the moment of truth.
Right, the famous Eddington expedition.
Exactly.
Hmm.
Sir Arthur Eddington, a British astronomer, led expeditions to observe stars near the sun during a total eclipse. The idea was if the sun is warping space-time, the light from those stars should appear slightly shifted from its normal position because it's bending as it passes the sun.
Yeah.
And Eddington's observations confirmed it. The amount of bending matched Einstein's predictions based on general relativity, not Newton's older ideas.
That must have been huge news.
Oh, it was explosive. Front page headlines around the world. Things like revolution in science, new theory of the universe, Newtonian ideas overthrown.
And just like that, Einstein wasn't just a brilliant physicist anymore.
No. Overnight, he became, well, maybe the world's first true celebrity scientist.
The wild hair, the gentle eyes, the guy who'd overthrown Newton.
Exactly. He became this global icon of genius. His name became synonymous with it. He captured the public imagination like no scientist really had before.
You can really see that celebrity status taking hold during his first visit to the U.S. in 1921.
Absolutely. It was a sensation. Ticker tape parade welcome in New York City by the mayor.
Wow.
Lectures at Columbia, Princeton. He even visited the White House. The press followed him everywhere.
And he seemed to like America, didn't it?
He did. He had this quote about Americans being friendly, self-confident, optimistic, and without envy. That trip really cemented his image as this international figure.
But as his fame grew, the situation back in Europe, especially in Germany, was getting darker.
Yes, dramatically so. By the early 1930s, the political climate was becoming incredibly dangerous.
The rise of the Nazis.
Exactly. And Einstein, being Jewish and an outspoken pacifist and internationalist, was a prime target for nationalist hatred.
So in March 1933, Hitler comes to power.
Mhm.
Where was Einstein then?
He happened to be visiting the U.S. again. And seeing what was happening, reading the news from Germany,
Yeah.
he made the decision. He couldn't go back.
A huge life-altering decision.
Immense. He knew his life would be in danger. The Nazi persecution of Jews was already underway. It just wasn't safe.
So what did he do? Did he just stay in the U.S.?
Well, first, while he was temporarily in Belgium, he went straight to the German consulate there and formally renounced his German citizenship. A very clear statement.
Wow. And how did the Nazis react?
Predictably badly. They denounced him, publicly burned his books, confiscated his property in Germany like his sailboat, apparently.
It's his sailboat.
Yeah, and they even turned his little summer cottage outside Berlin into a Hitler youth camp. Vicious, symbolic acts.
Just awful. So Germany was out. Where did he land permanently?
He was offered a position at the brand new Institute for Advanced Study in Princeton, New Jersey.
Ah, Princeton.
Yes, it was becoming a haven, actually, for many scientists and scholars fleeing Nazi Germany and Europe. He accepted the position and moved there.
And stayed there for the rest of his life, right?
He did. He became a U.S. citizen in 1940, though he kept his Swiss citizenship, too. Princeton became his home.
But even from the relative safety of Princeton, the events in Europe, especially the threat of Nazi Germany, must have weighed on him.
Hugely. And this leads to another really pivotal and, for him, deeply troubling moment. The letter to President Roosevelt.
Right, about the potential for atomic weapons.
Yes. On the eve of World War II, spurred on by other physicists like Leo Szilard, who were deeply concerned.
They feared the Germans might be developing an atomic bomb.
Exactly. They feared German scientists might be ahead. So, Einstein, using his immense prestige, signed a letter drafted by Szilard urging President Roosevelt to start a U.S. research program into nuclear fission.
The letter that essentially kicked off the Manhattan Project.
Pretty much. But it was something Einstein came to deeply regret later.
Really? Why?
Well, after seeing the devastation caused by the bombs dropped on Hiroshima and Nagasaki, he felt immense guilt. He famously said, "I made one great mistake in my life when I signed the letter to President Roosevelt,
Wow.
recommending that atom bombs be made. But," he added, "there was some justification, the danger that the Germans would make them." It shows the terrible moral dilemma scientists faced.
A heavy burden to carry. Now, Amidst all this world-changing science and geopolitical drama, he also had a personal life, which sounds like it was pretty complex too.
It was, often overshadowed by the science, but very human. He was married twice. First to Mileva Maric.
Another physicist he met at university, right?
Yes. They had 3 children together, though their first daughter, Liesl, born before they married, sadly seems to have died in infancy or been given up for adoption. The records are unclear.
And their sons.
Hans Albert, who became a successful engineering professor, and Edward, who tragically developed schizophrenia and spent much of his life institutionalized.
That must have been heartbreaking.
Immensely so. Einstein and Mileva eventually divorced. And interestingly, part of the divorce settlement was that if he ever won the Nobel Prize, the money would go to her.
Which it did.
Which it did. He later married his cousin, Elsa Lowenthal. And, well, letters released much later revealed he had other romantic involvements too, even during his marriage to Elsa. It paints a picture of a brilliant man, but one grappling with complex relationships and personal struggles, just like anyone.
It adds another layer to the icon, doesn't it? Makes him more real.
Definitely.
Okay, shifting gears a bit. Beyond relativity, what were his later scientific and philosophical interests? He famously wasn't entirely comfortable with quantum mechanics, was he?
No, he wasn't. This is one of the great ironies because his own work on the photoelectric effect was so foundational for quantum mechanics.
Right.
But he became deeply unsettled by its implications, especially the inherent randomness and probability. He felt it couldn't be the complete picture. That's where his famous quote comes from. God is not playing at dice with the universe.
He believed there had to be some deeper, deterministic reality underneath it all.
Yes. He spent the last decades of his life searching for a unified field theory, a single theory that could elegantly unite gravity with electromagnetism, and maybe reveal that deeper layer.
But he never found it.
No, unfortunately, he didn't succeed in that quest. It remains one of the biggest challenges in physics, even today.
His intellectual honesty, though, even in disagreeing with the mainstream, is pretty remarkable.
Absolutely. And that integrity extended beyond science into his social and political views. He was incredibly outspoken against racism.
You mentioned his connection to his Jewish identity helping him empathize?
Yes. He saw parallels between the discrimination faced by Jews and the racism experienced by Black people in America. He didn't just talk about it, he acted. He famously visited Lincoln University, a historically Black college, received an honorary degree, and gave a speech strongly condemning racism, saying, "I do not intend to be quiet about it."
That took courage, especially back then.
It did. And there's that wonderful story about the singer Marian Anderson. When she was performing in Princeton, but denied a hotel room because she was Black,
Einstein invited her to stay at his home.
immediately, he practiced what he preached. He felt his own experiences gave him a particular understanding, saying, "Being a Jew myself, perhaps I can understand and empathize."
Powerful stuff. He also had a strong connection to the idea of a Jewish homeland, didn't he?
Yes, he was a supporter of Zionism, though his views were complex. He was very involved in the founding of the Hebrew University of Jerusalem.
He helped raise funds for it.
Tirelessly. And he ultimately bequeathed his entire literary estate and personal papers to the university. A huge legacy.
What about his own religious beliefs? He talked about God, but not in a conventional way.
No, definitely not conventional. He felt a strong affinity for the philosopher Spinoza's idea of God.
Which is?
Sort of an impersonal, pantheistic God, meaning God isn't some person-like being intervening in human lives, but is revealed in the harmony, the order, the sheer beauty and intelligibility of the universe and its laws.
So finding God in the laws of physics, in a way.
Exactly. He called belief in a personal God naive. He described himself sometimes as agnostic, other times as a deeply religious non-believer.
A religious non-believer. That's quite a phrase.
It is. He said, "A spirit is manifest in the laws of the universe, a spirit vastly superior to that of man." He felt that pursuing science, trying to understand that spirit, naturally leads to a religious feeling of a special sort.
So the awe of scientific discovery was his form of religious experience.
Beautifully put, yes.
And we mentioned his love for music earlier, the violin. That wasn't just a casual thing for him, was it?
No, it was a deep passion, a lifelong companion. He apparently played quite well. He even performed chamber music sometimes with professional musicians like members of the Juilliard Quartet.
Seriously?
Yeah, and they were reportedly impressed by his musicality, his coordination and intonation. It just shows another facet of this incredible mind, that connection between mathematics, physics, and the structures of music.
A true Renaissance man, in a 20th century way.
You could say that. He remained intellectually active right up until the end. He passed away on April 18th, 1955. He was 76.
What were the circumstances?
He suffered a ruptured abdominal aortic aneurysm. He was in the hospital, and apparently he was working on a draft of a speech.
Working right to the end. What was the speech for?
It was for a television appearance commemorating the 7th anniversary of the State of Israel. His mind engaged with the world, with science, with his convictions, right up to the last moments.
An extraordinary life, right to the finish. His legacy, of course, is just monumental.
Immeasurable, really. His scientific theories underpin so much of modern physics and cosmology. That archive at the Hebrew University ensures his work continues to be studied.
And Time magazine naming him Person of the Century in 1999.
Yeah, that felt right. And surveys of physicists consistently rank him as, well, the greatest ever, or certainly among the very, very top.
There's that quote from J. Robert Oppenheimer, who knew him at Princeton.
Oh, yes. Oppenheimer said Einstein was almost wholly without sophistication and wholly without worldliness. There was always with him a wonderful purity at once childlike and profoundly stubborn.
Childlike and profoundly stubborn. That captures something essential, doesn't it? That relentless curiosity you mentioned right at the start.
It really does, that refusal to accept things just because they were accepted wisdom.
So thinking about his whole story, what's a final thought for us to consider? Maybe about that curiosity, that questioning. It seems relevant far beyond just science.
Absolutely. I think his life really challenges us. How willing are we in any field in our own lives to question the basic assumptions, to look deeper like he did with that compass, to pursue understanding even when it's difficult or makes us unpopular or leads us down unexpected paths, that relentless questioning? Maybe that's the core of the Einstein legacy that inspires everyone, not just scientists. What truths are waiting if we just dare to look?
A profound question to end on.
Thank you for your attention. If you enjoyed this deep dive, please subscribe to our podcast.
See you next time.